You have had a very brief introduction to logarithms and properties and logarithmic equations, but logarithms are actually very useful in real-life applications. Logarithms are used in the Richter scale, which models the magnitude of an earthquake. They're also useful for the decibel scale in measuring the loudness of sound, and they're also very useful in financial applications. In section 5.4.5, we will examine the doubling time for an investment. Example 6. How long will it take an investment to double at 4.2% interest if interest is compounded semi-annually? Let me remind you of our compound interest formula. A equals P times 1 plus R over N exponent NT. A is the amount in the account, P is our principal, R is the rate of interest in decimal form, N is the number of times interest is compounded per year, and T is time in years. In this example, we are asked, how long will it take the investment to double? So we are looking for T. T is unknown in this problem. We want our investment to double, but we don't know what the initial principal is. Notice there's no initial investment that's given here. We do know that the rate of interest is 4.2% and interest is compounded semi-annually. So we know here that we're looking for doubling time. If our initial investment is P, then the final result should be twice as much. So the output should be 2P for doubling time. Now, if that's too abstract, you don't like that, you can start with plug in $100 for principal and set your A at $200. Or plug in $1,000 for P and set your A for $2,000. We're going to find out that the answer to this problem is independent of the initial amount of principal. Continuing our details here, the rate is 4.2%. Remember, we write that as a decimal, 0.042. We just move our decimal 2 places to the left. N, since interest is compounded semi-annually, that means twice per year, and T is unknown. We're trying to figure out how long is this going to take? What is the doubling time? So to solve this for T, the first thing I'm going to end up doing is dividing both sides by P. So the P cancels on both sides. Again, this shows that the answer to this problem is independent of the initial amount. So it's going to take the same amount of time for $1 to grow to $2 as it is for $1 million to grow to $2 million. Now, if we simplify this base here, 0.042 divided by 2 is 0.021, and if we add 1 to that, we get 1.021 raised to the 2t. Notice this is an exponential equation. We cannot get like bases between 2 and 1.021, so we will go ahead and rewrite this in logarithmic form. So this will be log base 1.021 of 2 equals exponent 2t. We have converted this into a linear equation, and we need to solve for t. T is being multiplied by 2, so we will divide both sides by 2. So we end up with the exact value for t. T equals log of 1.021 of 2, all divided by 2. Now, don't be tempted to cancel the 2 in the argument position with the 2 in the denominator. The 2 in the argument position is not an ordinary 2. It is plugged into a logarithm. So log base 1.021 of 2 represents some irrational number. 2 just happens to be the argument. And the 2 in the bottom, that's an ordinary 2, but it's not the same as the value in the numerator. So this is our exact solution. It's going to take that many years, but for our brains to really comprehend that, let's figure out what that is. Let's approximate it. So I'm going to type in my shortcut, math alpha A. The base is 1.021 of argument 2. Make sure you get out of your argument with your right arrow key before you divide by 2. And our approximate value didn't tell us where to round, so let's just round to the nearest tenth. This would be 16.7 years. So t is approximately 16.7 years. Again, it's going to take 16.7 years for $1 to grow to $2, and it's going to take 16.7 years for $1 million to grow to $2 million. That's the amazing thing about doubling time. So that completes our last problem for notes. I want to commend you for making it this far and sticking with it. You deserve to celebrate, so congratulations for making it this far. You're ready to go complete your very last homework for the semester. That's also something to celebrate. And then proceeding on to that Unit 5 test. So good job. You should feel good about persevering and completing this class because not everybody does it. So great job and best of luck to you in your future endeavors.